Okay, so now to get into the notes of section 8.4 for arcs and central angles, I want to talk about something called arc length versus arc measure. Now this topic is going to be slightly new, but it does relate to something that we've already talked about. So let's read the sentence that's below the notes heading. It says arcs as well as angles can be measured in degrees. The measure of an arc is the measure of the central angle that intercepts it. Now I'm going to highlight this, and I want you to underline this as well on your paper because this is probably the most important sentence in this little note section. So I'll read it one more time. The measure of an arc is the measure of the central angle that intercepts it. And this word intercepts, remember, relates to that definition we had earlier above where I defined intercepted arc for you. So remember, that's the arc that's created by or across from any angle in a circle. So this last note I have here is sort of just a cautionary note. Make sure that you do not confuse the length of an arc with the measure of an arc. They are two very different things. And to show you what I mean, I'm going to use the circle below here, and we're going to find the length of arc AB, and then we're going to find the measure of arc AB so that you can see the difference in what I mean here. So finding the length of arc AB, we already know how to do this. We just learned this in our previous section. So this formula for arc length is x degrees out of your 360 degrees, and you multiply that with your circumference. So plugging in what I have here, I have 75 degrees out of the total 360 degrees, and I'm going to multiply that with 2 pi radius in this case, which is 8. So I have 75 out of 360 times 16 pi. And I'm going to write that over 1 so that I have two different fractions that I can just now multiply across. So why don't you take a few seconds to make sure you have that written down. Okay, so multiplying across, if I multiply 75 with 16, I get 1,200, and I have a pi, don't forget, so it's 1,200 pi, all over 360 times 1, which is just 360. So from here, since we're talking about a length, our units are going to be centimeters, and you have a few different options. You can just say that you're done and that this is your final answer. I would not mark this as being incorrect. However, it is important to note that this is not the fully simplified answer. So I do want you to write down the simplified answer. And what I mean by simplified is that I mean you can take 1,200 and divide that by 360. I'll do that in my calculator here. Oops. So I'm going to take 1,200, divide that by 360, hit enter, and I get this long decimal. My calculator has a function where I can hit this button called math, and then the first option is turn that into a fraction. And we see here that 1,200 divided by 360 as a reduced fraction is 10 over 3. So going back to my notes here, I'm going to rewrite 1,200 pi divided by 360 as 10/3 pi centimeters. So again, not to confuse you, these are both correct answers. However, this answer is the simplified final answer. Okay, so this should have been reviewed. We have done this and we have found the length of arcs. The new thing that we're going to do today is we're going to find the measure of arcs, which is different from finding the length. Now, the measure of the arc, again, if we go back to this sentence underneath the notes heading, is the measure of the arc is the measure of the central angle that intercepts it. So if we look at arc AB on our diagram here, if we want to know the measure of this arc, all we have to do is look at the measure of the central angle that intercepts it. So there is a little notational thing that I want you to write in this blank. When it says find the measure of arc AB, or written as blank, the notation for the measure of the arc would be written like this: measure, little m, and then AB with the arc symbol above it. So this one's pretty straightforward. If I want to know the measure of arc AB, I'm going to say the measure of arc AB equals 75 degrees. And we're done. So the measure of the arc was a lot quicker than finding the length of the arc. But please note the difference. The length of the arc was an actual value with units. It was 10^3 pi centimeters. And the measure of the arc was just the measure of the central angle that intercepted arc AB. So the measure of arc AB was 75 degrees. The last kind of note I want you to take on this page is that there can be a connection made between the arc and chords. So the note says here that two chords are congruent if and only if their corresponding arcs are congruent. So let me show you what I mean here. So this is saying that if arc AB, I'm sorry, that's not an arc. If chord AB, which is a segment, is congruent to chord CD, which is also a segment, then we can make the conclusion that arc AB is going to also be congruent to arc CD. And this is just a theorem that we might apply in a homework or later on a problem or a future problem. So I just wanted you to be aware of this. But it should be pretty straightforward that if two chords are congruent, then their two corresponding intercepted arcs will also be congruent.